We're going to go through a review section by section here, starting with z-scores, and look at what are the most important things we need to know about these and how we're going to use them. So first of all, a z-score is the number of standard deviations from the mean that a value falls. So if you have the value 2 and the mean is 3, it is 1 less than the mean. But what I want to know is how many standard deviations is that? Let's say the standard deviation is 4. Well, then being 1 away is really only 1/4 of a standard deviation. And so we'll explore that through the examples coming up. But the idea is how many standard deviations you are from the middle. 3 components of z-score formulas. They all essentially look the same, and I'm going to write it down here. So the basic z-score formula is going to be z is equal to the value that you're interested in minus the middle divided by the standard deviation, the spread. So your value, how far is it from the middle, the distance from the middle, that's why we subtract, divide that by your spread, your standard deviation, your standard error. So those are the main 3 things we're looking for. For find a z-score given a value, let's say we know that we want to find it for 6 when the average is 9 and standard deviation is 2. So the value that we care about is 6, the average is 9, and we're going to divide that by 2. So we are 3 below the mean, we are -3, and in terms of standard deviations, that would be -1.5, or 1.5 standard deviations below the mean. Now, this next one gets into the idea of the central limit theorem. Now, instead of just having a standard deviation down there, we're talking about standard error. We're talking about spread of a sampling distribution. So, central limit theorem gives us a new sampling distribution when we're taking a graph, not just of values, but of a bunch of x-bars all graphed together in a sampling distribution of means. So, for example here, switch colors, find the z-score for a sample average of 84. So now what we're doing is we're finding not x but an x-bar, a sample average, and we're going to compare that to the population average. We're going to divide that by the standard error, which we know to be sigma over square root n. We divide by square root n because our sampling distribution has a smaller spread than our starting distribution, because when you take a bunch of averages you get closer together. That's the central limit theorem at work. So let's plug these values in. We have a sample average of 84, and we're comparing that to the population average of 75. So we are larger than average. We are 9 above average. How does that compare to the spread though? How many standard deviations is that? We would divide it by 14, but not so fast. We have a sample of 12. So not just dividing it by 14, but 14 over square root 12. And I put that in parentheses mainly so that when you're typing it into your calculator, you remember that that matters. Sometimes a lot of people like to do this in 2 steps, and when I show my work I like to do this in 2 steps because that way it makes it a little bit easier to keep track of what's going on and not mess up parentheses. So this comes up to about 4.04 on the bottom, and if we take 9 divided by that answer without taking it out of our calculator, so no rounding here between steps, we get 2.2 and round it off to 3, so 2.23, and that would be the z-score. So find the z-score, there it is. It's your last step. Alright, last one says work backwards from a z-score to get the value. So if we have a z-score, let's say in this example it says of 1.5, and we're given the mean and standard deviation, how long did it take them? 1.5 tells me it's above average. So if the mean time is 5 minutes, looking at this one here, if the mean time is 5 minutes, I am going to be above that, 6, 7, I don't know, but it's something above 5, positive z-score. Standard deviation is 2. So if I was 1 standard deviation above average, I would be 7. 1.5 standard deviations above average, I'm a little over 7, maybe 8 or something. So let's try this out. We could mathematically adjust this equation here and multiply both sides by sigma. And then we could add on the mu to both sides. So we get z times sigma plus mu. So we could solve this algebraically and get this formula, or we could kind of do it more intuitively to say, I start with 5 minutes and I add on 1.5 of the standard deviation, 1.5 times the standard deviation. So 1.5 times 2 is 3. And I add that above my mean of 5, so that gives me 8. So you can do it algebraically or you can do it kind of more intuitively, but either way, 8 minutes is going to be the value of 1.5 standard deviations above the mean. And that is the core review for z-scores.